Well, hello everyone. I am going to finish up yesterday's lesson 5.1 and 5.2. The first time I recorded the lesson, it was way too long. It was about 41 minutes, and that's way too long. So yesterday's lesson was 27 minutes, so this is going to be about 13 minutes, maybe a little longer. So excuse me, I was going to include this on yesterday's lesson, but it was too long, so I just decided to give it to you today. Okay, so today we are going to take a look at quadratic transformations. And so looking at the vertex form will tell us right away what's going on with the quadratic function. So we'll take the parent function, f of x is equal to x squared, and we'll change some things about it. We'll change the way it looks. Remember yesterday I told you that a, h, and k were like constants? Today we'll actually take a look at what effect does a, h, and k have on the parent function f of x is equal to x squared. I will be using Schoology, not Schoology, but Desmos, and I'll be demonstrating some of these transformations. And I encourage you, when you're doing your homework, particularly as we move forward, use Desmos to kind of help you see the picture and maybe even check your work. I could have shown you how to solve a system of equations using Desmos. I did not want to. I want you to know how to solve a system of equations by hand, but Desmos can do it for you. In any event, I want you to notice here, so I'll go over some things with Desmos. Down here is this like little keyboard. So I am going to type in the parent function, so f or y. I don't know if Desmos can use f of x maybe, but y equals, and I'll just, so x squared. Now you see this a squared, so I'll just type a and then the square button. Okay, so there's the parent function, y is equal to x squared, and we'll be making transformations to that parent function. Notice here that the vertex is 0, 0. Okay, that's the parent function. Now, so what we're going to do, so to begin, because the vertex is translated h horizontal units and k vertical from the origin, the vertex of the parabola is hk, and we talked about that yesterday. Helpful hint, when the quadratic parent function f of x is equal to x squared is written in vertex form, y equals a times x minus h squared plus k. A is just equal to 1, h is equal to 0, and k is equal to 0. In these transformations, a can never equal 0. For if a is equal to 0, we just have 0 times x minus h in parentheses squared plus k, or we just have the equation y is equal to k, which is certainly not quadratic. It's linear. It's a horizontal line. So a can never equal 0. So let's look at some transformations. So we have the description, translate 5 units right. So a is still going to equal 1. H now will equal 5, and k will equal 0. So we use something different for the transformation. The parent function, we like to use f of x. When we do transformations, we'll say like g of x. So g of x will equal to x minus 5 in parentheses squared. So if I go back out to Desmos, okay, I'll show you. So y equals x minus 5. And I do a shortcut. I use the caret key as like that greater than sign, or greater than sign, caret. Okay, so there it is. So you see that the transformation, the graph did go 5 units to the right. Notice that my vertex is 5, 0, h is 5, and k is 0. So I'll write that. My vertex is 5, 0. So I'll write the vertex there. So that was 5. The vertex equals 5, 0. Again, that's why we call it the vertex form. So that was translating 5 units right. Let's look at the next one. So we're going to translate 3 units left. So a will still equal 1. Now h is going to equal negative 3, and k will equal 0. So if I go back to, so that was x minus 3. So minus will be a plus, so that would be plus, and then 3. And there you see. So the graph shifted to the left 3. The vertex is now negative 3, 0. Okay, so my vertex is negative 3, 0. I'll abbreviate. So v, the vertex is equal to negative 3, 0. Okay. Let's look at the next one. Vertical stretch by a factor of 4. Oh, so let me go back up here. So A will do three things for us. It will reflect across the x-axis, and it will do a vertical stretch or vertical compression. H will move things left or right, and K will move the graph up or down. Okay, so, and you should remember those three things. A does three things: reflect, compress, and stretch. H moves left or right, K moves up or down. So here we're going to vertical stretch by a factor of 4. Okay, so now A is going to equal 4. We're not going to move the graph left or right anywhere, and we're not going to move it up or down. We're just going to stretch it 4. So you'll see what I mean. So this would be 4x squared. We stretched it by a factor of 4. So notice the blue graph is like we took that red graph and we pulled up on it. We stretched it. We stretched it there. Okay, but notice that the vertex H is 0 and K is 0. The vertex is still 0, 0. So now my vertex is equal to 0, 0. Still, vertex equals 0, 0. Let's look at the next one. So here we're going to do a vertical compression by a factor of a fourth. So A will equal 1/4. H is still going to equal 0, and K will equal 0. So I'll go back out there and I'll do, so this will be a vertical compression. And so you'll see it will look like we took that graph and we compressed it down. So in parentheses, 1 divided, oops. Well, 1 divided by 4. And then parentheses. And then I want x, and then raise that to the 2. Okay. So it looks like we took that red graph and we pressed down on it. So we call that a vertical compression by a factor of a fourth. Again, the vertex is still 0, 0. Okay. So my vertex is still 0, 0. Let's look at the next transformation. So now we're going to reflect across the x-axis. So A will now equal negative. Remember yesterday I said that if A is negative, then we'll have a sad graph. If A is positive, we'll have a happy graph. So here we're just going to reflect across the x-axis. The important thing is this here, is that negative x squared means just that. It does not mean we take x and make it negative and then square it. No. Okay, so if that was the case, if x was 2, then we have a negative 2, and negative 2 squared would be 4. This says here we would just take, 2 squared, and then we would take the opposite, or get a negative 4. Okay, so don't make that mistake. Negative x squared is not, you take x, make it negative, and square it. So we're going to reflect this across the x-axis. So x is going to be, oops, negative, so negative x raised to 2. There we go. We reflected it across the x-axis. All right. So again, the vertex is still 0, 0. The only thing that changes the vertex is H and K, not A. So the vertex is still 0, 0. Again, the only thing that changes the vertex, moves it, is H and K. Now, we'll look at a vertical translation down. Again, A is equal to 1. We're not going to move anywhere left or right. H is equal to 0, but now K will equal negative 3. Okay, so let's take a look at that. So we'll have x raised to 2, and then minus 3, I think I said. Let me go back here. Oops, minus 2. So notice that my graph shifted down 2 units. Okay. The vertex, however, is now 0, negative 2. H is still 0, but now K is negative 2. So my vertex here will be 0, negative 2. Okay, so let's look at some more. Here, vertical translation up 3 units. A is going to equal 1, h is equal to 0. We didn't move it anywhere left or right, and then k will equal 3. So we'll move it up 3. So this, if I just change this to plus 3, you'll see that it moved up 3. Now my vertex is 0, 3. Okay, I moved the vertex up 3. Okay, so vertex equals 0, 3. All right, now we can combine many transformations. Okay, so let's do a couple here, which is the type of things you do on a quiz or test. So number 8, we're going to vertically stretch by a factor of 4. So we'll change a, and then we'll reflect across the x-axis now, and then so we'll make a negative. Okay, and so a will equal negative 4. We're doing two things to a, making it negative, and we're stretching it by a factor of 4. The vertex is still going to be the same, so negative 4x squared. So let's take a look at that. So negative 4x raised to the second. Just want to make sure that that was right. Yep, negative 4x squared. So notice, again, it's like we took that red graph, the parent function, we stretched it, we pulled up on it, and then we reflected it. The vertex is still 0, 0. We didn't move anywhere left or right. The vertex still stays at 0, 0. I think you guys are getting the hang on this. Okay, number 9, just 2 more to go. Vertical compression by 1/2. So by a factor of 1/2. So we're going to press down on the graph. Translate at 5 units left and then 3 units down. So we have like 3 transformations going on here. So let's take a look at all 3. Okay, so I said vertical compression by a factor of 1/2. So 1 divided by 2. Oops, why did that? 1. Why is that giving me 9? Okay, because I have caps lock on. 1 divided by 2. And then we're going to translate it left 5. So x plus 5, left 5, x minus negative 5. And then we'll raise that to the 2. And then, and again, when I do my square, I use my caret key, and I'll show you what the caret key is in just a minute. I don't use what's in the keyboard down there. I do the shortcut. And then minus, so I have to go over, and then minus 3. Okay, so let me just make sure. Yep, I compressed the graph by a factor of 1/2. It's like I pushed down on the red graph, made it flatter. I moved the vertex over to the right, or to the left 5. H is negative 5. And then down 3. Okay, so my vertex is negative 5, negative 3. All right, and then finally, we'll do a vertical stretch by a factor of 5. We're going to reflect across the x-axis, and then we'll translate up 4. So let's take a look at everything there. So, okay, so a will equal negative 5. That's the reflection. The reflection is negative. The vertical stretch is 5, so negative 5. And then we don't go anywhere left or right, but then we go up 4. So let's take a look at the final one here. So this is going to be, so negative 5x caret key squared, and then plus 4. Okay, so let's see here. So you see the reflection across the x-axis. It's a sad graph. You see that it's been stretched vertically by a factor of 5. It's like we pulled that red graph up. We stretched it like a rubber band, and then we moved it up. Then we moved it up there. We moved it up 4. So the vertex then, so the vertex will be, so h is equal to 0, and then k is equal to 4. All right, so I would suggest as you're doing these problems and for the remainder of the school year, work with Desmos. Desmos will help your understanding a lot. And the caret key I was using when I was doing the square looks like that. Okay, so I wasn't actually using the keyboard. All right, I was using the caret key when I said X, and then so it would be like this. This is what I entered: X caret key 2, and I gave it x raised to the second. In any event, guys, that is the lesson for today, and then you'll have some homework posted.